1, 2, 3. During these 3 seconds when I counted, the universe continued expanding at a rate of 70 kilometers per second per megaparsec of space. Though we cannot feel it, this cosmic expansion stems from the Big Bang almost 14 billion years ago and carries galaxies apart over gigantic distances. In the time it took me to count to 3, nearly 10 million black holes collided and merged somewhere in our vast universe. These mergers release tremendous energy as the black holes spiral inwards and eventually become one. In our universe, 1,000 stars explode every second, releasing energy billions of times greater than that produced by the sun. Estimates range from 1 to 10,000 stars exploding per second. This number should be taken with a grain of salt. To have a star explode, it first needs to be much more massive than the sun. When such a star runs out of fuel to burn, it succumbs to its own gravity and begins collapsing inward. During this collapse, the pressure at the core of the star becomes so great that electrons and protons fuse together, forming a neutron star, while the remaining matter is explosively expelled, creating an unparalleled explosion and a shockwave that propagates throughout the interstellar space. Eventually, all that remains is a tiny neutron star, or, worse, a black hole. There are other scenarios where a supernova can occur, but it will be for another time. Every second, the Voyager 1 probe travels 17.1 kilometers heading towards interstellar space. Voyager 1 is a probe that was launched in 1977 with the purpose of studying the largest planets in our solar system, namely Jupiter and Saturn. After passing them in 1981, which took 3 years, the probe was redirected to fly past Uranus and Neptune. Voyager 1 has discovered the moons of Jupiter and provided detailed images of Jupiter's Great Red Spot. It has also studied the atmosphere of Saturn and accomplished many other useful tasks. Today, the probe is located 22 billion kilometers away from Earth, beyond our solar system. Every second, our universe expands by 70 kilometers per megaparsec. To put it simply, let's consider a type of star called Cephids. They are variable stars that vary in brightness due to pulsations. These stars are mostly very luminous, and the brighter they are, the slower their pulsations or variations in brightness. From Earth, astronomers observe the variation of a Cephid star located in a distant galaxy. By determining its absolute magnitude, the goal is to obtain its distance. As you may know, the farther away an object is, the less bright it appears to us. For example, if the sun were 5 light years away from us, we would be much less illuminated. So, the speed of pulsation of Cephids allows us to categorize their true luminosity. By comparing this luminosity, known as absolute magnitude, with the brightness we see from Earth, known as apparent magnitude, we can calculate the distance. By analyzing a Cephid star in another galaxy, we can determine the distance to that galaxy. This information, combined with observations from other galaxies, has allowed scientists to infer the expansion rate of the universe. Currently, it is estimated that the universe is expanding at a rate of approximately 70 kilometers per megaparsec per second. A megaparsec is a unit of distance equal to about 3.26 million light years. So, for every megaparsec of space, the universe expands by 70 kilometers every second. This expansion is a consequence of the Big Bang, the event that is believed to have given birth to our universe. The Big Bang theory states that the universe began as a hot and dense singularity about 13.8 billion years ago. From that moment, it has been expanding, with galaxies and other cosmic structures moving away from each other. It's important to note that this expansion does not mean that galaxies are physically moving through space like objects on a conveyor belt. Instead, it's the fabric of space itself that is stretching, carrying galaxies along with it. Imagine a balloon being inflated. While the balloon expands, the dots on its surface move away from each other, even though they haven't actually moved within the balloon. In addition to the expansion of the universe, numerous other phenomena occur every second. Stars are continuously being born and dying throughout the cosmos. Stellar nurseries, regions of gas and dust, give birth to new stars, while others reach the end of their lives and explode as supernova. In fact, it is estimated that around 300 stars are born in the universe every second. These stars form from the gravitational collapse of dense regions within molecular clouds. As they condense and heat up, nuclear fusion ignites at their cores. generating the immense energy that allows stars to shine. The exact number of star births per second can vary, as it depends on the rate of star formation in different galaxies and regions of space. Simultaneously, stars are also dying. As I mentioned earlier, supernovae occur when massive stars exhaust their nuclear fuel. The explosion releases an enormous amount of energy, and the remnants can either form neutron stars or collapse into black holes, depending on their mass. It is estimated that thousands of supernovae occur in the universe every day, equivalent to around one every second. These are just a few examples of the fascinating phenomena that take place in the universe every second. From the vast expansion of space to the birth and death of stars, our universe is a dynamic and ever-changing place. Exploring and understanding these phenomena is a constant pursuit of astronomers and scientists, pushing the boundaries of our knowledge and revealing the wonders of the cosmos. And that concludes our intergalactic journey. Be sure to check our channel for additional videos further exploring some of these amazing topics.